So the divisor is in descending order. I already wrote it. Now I'm looking at the numerator, and the numerator has degree 3. Degree 3 is there. Degree 2 is there. Degree 1 is there. Degree 0 is there. There is no need to leave any room or space. Good. So 6x squared times what is 6x cubed is just x. I go back and distribute to all three terms. I need to change the sign and then write under like terms. Positive 6x cubed, negative 6x cubed. Positive 3x squared, negative 3x squared. Positive 9x, negative 9x. Don't ever look at what you see here. You just have to write them correctly under like terms. Don't try to change what you write based on what you see above. No, 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 no. So this is negative 6x squared, and this is negative 6x, and then plus 8. 6x squared times what is negative 6x squared? The answer is negative 6. Negative 1. Negative 1. So negative 1, distributed, change the sign, and write under like terms. Negative 1 times 6x squared is negative 6x squared, change. Negative 1 times 3x is negative 3x, change. Negative 1 times 9 is negative 9, change. Gone, negative 3x plus 17. And this has to be boxed in. Why? Because 6x squared doesn't go into negative 3x. I'm done. It's degree 1 is degree 0. There is nothing else. I will never be able to write anything else. Degree 1, degree 0. There is no more. So therefore, I'm going to write the answer S, the quotient, plus, you can write plus and write S is negative 3x plus 17 over the divisor, or you could also write this, x minus 1 minus 3x minus 17 over 6x squared plus 3x plus 9. Remember, with the long division, you don't need anyone to tell you, hey, you made a mistake, or you know what, you're correct. No, 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 no. We don't need anybody. All I have to do is multiply this by this, subtract 3x and add 17 to get this. If I don't get it, I'm not going to enter it because I'm going to waste points or lose points, right? So let's do it. This times this plus this has to give us this. If it doesn't, this makes no sense. I'll cross it out and say mistake. Okay. X times 6x squared. X times 3x. X times 9. Negative 1 times 6x squared. Negative 1 times 3x. And negative 1 times 9. Minus 3x, but plus 17. So let's see. This is okay because it's alone. 3x squared minus 6x squared is negative 3x squared. So these are all accounted for. Negative 3 with negative 3 is negative 6x. 9x minus 6x is positive 3x. All these are accounted for. And 17 minus 9 is positive 8. That's it. 6x cubed, here it is. Negative 3x squared plus 3x plus 8. Negative 3x squared plus 3x plus 8. That's how I catch any mistake. And I don't need anyone to tell me whether I'm correct or not. What was the difficulty or the issue here? So I know.
I just, for some reason, I was getting x plus 1 instead of x minus 1. I think that's why I was getting it wrong.
I see, I see. Perfect. Good. What are we going to continue with, please? Okay, Imani, do you need anything? Do you want any topic? Hunter, any topic? Shay, any topic? Christy?
Can we do another one like that? I'm not able to share my screen though.
You mean like this one?
Mm-hmm.
Yeah, so you can read one for us.
Sure.
That's fine. Any problem?
So I have 2x to the 4th minus 4x squared plus 3x over x minus 4.
Perfect. You want to use the long division? You want to use synthetic division? Because in this case, both work.
Can I see how you kind of work through it? Because I am still kind of confused on this overall problem.
Yes, but do you want long division or you want synthetic division?
Long.
Oh, sure. Good. So let's start. X minus 4 is a divisor. Now I look at the numerator and I realize it has degree 4. So 2x to the 4th is the leading term, but there is no term with x cubed. So I'm going to leave some space. But then the next one is negative 4x squared. The next one is positive 3x. And I know the missing term, the free term is missing, but I don't care. It's at the end. I don't need anything. The space will resolve by itself. Good. So x times y is 2x to the 4th. We have 2x to the 3rd. We have to go back and distribute it to both terms, change the sign, and write under like terms. 2x cubed times x is 2x to the 4th, but I have to subtract. 2x cubed times negative 4 is negative 8x cubed, but I have to subtract. I cannot write 8x cubed under anything else, so it has to go under the empty space. Bring down 8x cubed and bring down the next in line. Is this okay so far?
Yep, that makes sense.
X times what is 8x squared? X cubed is positive 8x squared. 8x squared times x is positive 8x cubed, but I have to subtract. 8x squared times negative 4 is negative 32x squared, but I have to subtract. When I subtract a negative number, I get a positive. When I subtract a positive number, I get a negative. Perform the operations I see. Bring down the next in line. X times what is 28x squared? Well, positive 28x. You cannot go back. Degree 3, degree 2, degree 1, and maybe degree 0. X times what is 28x squared is 28x. So 28x times x is 28x squared, but I have to subtract. 28x times negative 4, I think it's 112, correct me, negative, positive. We can always check at the end and see. But let me check again. 2 and 3, yes, that's correct. Good, this is gone. And this is 115x, and there is nothing else to bring in. If you want, you can put 0. So x times what is 115x? Okay, it's positive 115. Positive, negative 115x. Negative, so I have positive, I think it's 460. So then the answer would be the quotient, 2x cubed plus 8x squared plus 28x plus 115, and then plus 460 divided by x minus 4. What I am going to do to check is something much simpler than you would expect. I'm going to put in the graphing calculator in y equals. I'm going to put the original polynomial, 2x to the fourth. Oh no, that's not what I meant. Okay, go back. 2x to the fourth, x to the fourth, okay, plus 8x, minus 4x cubed, and plus 3x cubed, and plus 3x. And I'm going to use the remainder theorem. I'm going to plug in this polynomial, I'm going to plug in 4. And if the answer is 460, then I check the remainder. If the answer with 4 is not 460, I'll have to go back and check my answers. Okay, it's not 460. Good. So, okay, did I enter that correctly? Yes. So x times 2, so 2, positive, negative, negative, positive, 8x cubed. Good. Bring down negative 4x squared. Good. Now 8x squared, positive, negative 8x cubed, negative 32, positive 32. 32 minus 4 is 28. Correct. Bring down the next line. Correct. 28. Correct. Okay, I'm calculating this. 2 and 3. 4 times 2 is 8, plus 3 is 11. Correct. So do I get 115? Yes? Yes, I do. And 15. Okay, now I have to multiply 115 by 4. I think I'm correct. Maybe it's 3. What am I doing? Okay, so let's see. 2. I think I'm correct. So it's negative, positive. Okay, let's check again. The remainder has to be 460 if I'm correct. Let's see what I entered. I entered 2x to the fourth. Got it. This is squared. It's not cubed. Okay. Okay, now the answer has to be 460. And it is. So I know that this is correct. I entered x squared instead of x cubed. X cubed instead of x squared. So I don't have to check anything. I checked using the remainder theorem, meaning in the original numerator, I plugged in 4. And I got 460. So I know the rest is correct.
Thank you.
My pleasure. Other questions? Christy, do you have anything for us? Hunter, do you have anything for us? Emily, do you have anything else?
We do like a rational function with like graphing.
Yes, absolutely. Please choose any problem. Yes, yes, yes. Any. If you want me to open the book, I can open the book. If you want to choose from your homework, we choose from your homework. Choose from anything.
Can we do x plus 1 over x squared plus 2x minus 3?
Like this?
Yes.
Perfect. Good. So the first thing I have to do is factor the denominator. And I see an x plus 3 and an x minus 1. So x squared minus 1. What am I doing? X squared plus 3x minus x. Yes, everything is correct. Good. So because it's type 2, y equals 0 is the horizontal asymptote. no factor goes away, meaning that x equals -3, oops, not two negatives, x equals -3 is a vertical asymptote as well as x equals 1. No factor goes away, there is no hole in the graph. So x equals -3 and x equals 1, both are vertical asymptotes. I start the table. I know the domain. So -3 and +1. X equals -3 is a vertical asymptote. X equals 1 is a vertical asymptote. 0 and 0. Y equals 0 is a horizontal asymptote. When I plug in 0, 0, 0, 0, -1/3. But also, the numerator can be 0. So at -1, the function is 0. A fraction is 0 when the numerator is 0. And the numerator is 0 at -1. Now I know what happens left and right of the vertical asymptote. But I don't know the sign. So I'll have to plug in 0.9. Notice that I put them so high up that I'm not going to use them. I'm only using them to find the sign. I'm not going to plot those. So -3.1 and -2.9. So with -3.1, negative, negative, negative. With -2.9, positive, negative, negative. With 0.9, everything is positive except this. And with 1.1, everything is positive. And that's it. I'm done. When we graph functions with asymptotes, we have to graph the asymptotes first. -3 and +1. X equals -3, x equals 1. And now I'm ready to, and of course y equals 0, it's an overkill. This is the horizontal asymptote, which is the x-axis. I look at this, from 0 down to -infinity, easy. From +infinity, -1, 0, and 0, -1/3, and it's going to -infinity. From approaching the vertical asymptote at +infinity, crossing the x-axis, crossing the y-axis, going to -infinity on the left-hand side of x equals 1. On the other side, easy, from +infinity to 0. And this is the graph of f of x equals x plus 1 over x squared plus 2x minus 2. Of course, you can always check with the graphing calculator. In y equals, be very careful how you enter the function. You put parentheses around the numerator, which is x plus 1. Do not forget to put parentheses around the denominator, which is x squared plus 2x minus 3. Close. If you had a different horizontal asymptote but not 0, you will have to enter it separately. But this one is 0, so it's the x-axis. I don't need anything. The standard viewing window will work because we already graphed the function. We know what's happening here. So here it is. Do not copy something like this from the graphing calculator. The function does not overlap with the x-axis. Okay? So it crosses at 0. I'm sorry, -1, 0. You see the vertical asymptotes are missing. You have to graph them. It crosses at 0, -1/3, and then approaching the second vertical asymptote towards -infinity. Then it's coming from +infinity and going to 0. Going to 0 means eventually, not at -10 or the -4, they overlap. No, 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 no. Please do not copy something like this. And that's it. Any questions on this problem? Any questions? Okay, what is the next topic you'd like to go back to? Anything?
Can we go over how to identify vertical and horizontal asymptotes?
Yes. Yes. So it depends on what type it is. If it's type 1, leading coefficient over the leading coefficient, meaning if the degrees are the same, leading coefficient over the leading coefficient. That would be the horizontal asymptote. And for the vertical asymptotes, when the denominator is 0, because the fraction is undefined. But we have to make sure that the numerator does not have similar, identical factors that can be removed. So like here, on this last problem that we worked on, I realized that the denominator has these two factors that are not in the numerator. So both of them have to be vertical asymptotes, x equals -3 and x equals 1. Because at these numbers, as you see, the function doesn't exist. It has a vertical asymptote because the function does not exist at those numbers. That's where the rational function has vertical asymptotes. But if the factor disappears, so if, for example, if I had here x equals -1 and here x equals -1, this factor will disappear. The function will still be undefined at 1, but it will have a hole in the graph, not a vertical asymptote. So please go back to, sorry about that. So please go back to the videos, because we had examples of both, like this one and like that one with a hole. Is this better concerning the vertical and horizontal asymptotes? Of course, for type 2 is even easier, like this one that we just had. This is type 2 because it has a higher degree in the denominator. Because it's type 2, very easy. I don't have to calculate anything. The horizontal asymptote is 0. Well, if it is type 3, it does not have horizontal asymptote, but it has a slant asymptote. Good. Is this okay?
Yes.
Perfect. Next question. Next topic, anything else you want to look at? Is this okay, Christy?
Yes, it's okay. Thank you.
My pleasure. Anything else? Okay, what is the next topic that we want to review? Tell me what you need help with so you can finish and be ready for Wednesday. Please, anyone. Can anyone name another topic, please? Well, in that case, can I start chapter 4? You decide.
I have some more stuff on my homework. that
Yes,
I struggled
yes,
with.
yes, I'm anxious to look at it. Yes, please. Anything. We're ready. Anyone, anything you need help with, please.
Can you see it?
Yes, I can. Follow this 7-step strategy. Okay, very good. So this is what we just did. So we have 7x divided by x minus 3. Okay. Good, you can stop sharing. Once you present everything in the table, you're done. You don't need to write a 7-step procedure. Because if you write a 7-step procedure on 3 pages and you don't summarize it, it doesn't mean anything. So that's why I'm using this table. Because only the table, only if I summarize everything condensed in this tiny table, I can convert it into the graph. If I have all this information on 7 pages, I will not be able to come up with the graph. I will have to get the graphing calculator and cheat and, you know, copy from the graphing calculator. I will not be able to. But once you have all this information summarized in the table, it's very clear. It's coming from 0 going to negative infinity. This is the vertical asymptote. That means it's coming from positive infinity crossing the x-axis, the y-axis going to negative infinity on the left-hand side of this asymptote. And then on the other side from positive infinity to 0. But if you have all this information on several pages, no one can come up with this graph. I mean, you can write it on 7 pages or 3 pages, but then summarize it, and from the summary, you can come up with a graph. So I don't like this writing and writing and writing and not summarizing, not condensing it to see what I'm doing. Of course, I will never plot these. These numbers are only to check the sign of infinity. Okay, back to our problem. So I know that you can tell us step by step what they are asking, so we can fill in as they want. But I know that this function is undefined at 3. They're asking about symmetry. Perfect. Well, if you remember, for the symmetry, I have to determine this. If a function has a vertical asymptote at 3, which it has to be, it cannot be symmetric with respect to anything. If it has a vertical asymptote, then negative 3 and positive 3, yeah, maybe. But if it only has one vertical asymptote, there is no way. So when I plug in negative x, this changes and this changes. It will not equal f of x, and it will not equal negative f of x. You don't have to stress over this. The function cannot be symmetric. Okay, when I plug in 0, I have 0. I know it's type 1 because the degrees are the same. So then the horizontal asymptote must be 7. 7 over 1. So y equals 7 is the horizontal asymptote. 3 is the vertical asymptote. I know infinities. But we're going to answer the steps as they want. I just want to graph it, and then we'll answer step by step as they wanted us to answer. I will plug in 2.9 and 3.1. Numbers that are very close to 3, left and right of 3. 2.9 is quite close to 3. 3.1 is quite close to 3, but they have to be on one side and also the other. When I plug in 2.9, this is negative. The top is positive. When I plug in 3.1, both are positive. Done. I don't want you to stress over this. This is not something that should take more than a couple of minutes. So first I have the horizontal asymptote. 1, 2, 3. I'm going to say 2, 4, 6, 7. So this is y equals 7. I have to graph the vertical asymptote as well. X equals 3. And I have everything here. So it crosses at the origin. It's coming from 7, crossing at the origin, going to negative infinity. Done. On the other side, from positive infinity to 7. Finished. Yes, it looks difficult. And it is difficult if you need to go through 10 steps. But if you fill out the table as I asked you to, and I showed you all this time, you will have 0 difficulty. But now, Emily, if you'd like to share the screen again, so we can answer step by step. Once we have all this, you can answer everything. Okay, so the first question is, no, it cannot be symmetric by any means. It has a vertical asymptote of 3. Absolutely not. Then, what is the y-intercept? The y-intercept and the x-intercept are the same, 0, 0. When x is 0, y is 0. See, oh, okay. Type an integer. Okay, yes. What are the x-intercepts? Same thing, x equals 0. It passes through the origin. Done. Find the vertical asymptote. There is only one. X equals 3. Type an equation. Exactly. That's it. Horizontal, we know. It's 7. No, y. Horizontal asymptote is y equals 7. Good. Plot points. No need, but let's do it. So let's take, stop sharing for a second. So I'm going to share, put it in the graphing calculator. Here it is. In y equals, careful how you enter it. 7x is okay because it's only one term, no parentheses. But you have to put parentheses around x minus 3. And now just give me those numbers. What do they want? What was -6 or something, the first one?
Yeah, give me 1 second. It was -6.
Good, -6.
And then
The next
and
one.
then the next one was -2,
Okay,
+1,
okay.
+6,
A waste of time.
and +8.
Okay, waste of time. There is no need for any of that. But you can get them in a blink. Now careful, because I don't know what decimal digits they want. Rounding, la la la. Maybe they want a fraction. So if they want a fraction, be very careful. I guess I didn't read the fine print. So let me write down these numbers for us. So 4.667, the next one 2.8, -3.5, 14, and 11.2. Okay, now you can share. What did they want? Let's read the fine print. Simplify your answers. So plot points, la la la. Simplify your answers. So when we plug in -6, the numerator is -42, and the denominator is -9. So we have to write 42 over 9. Yep. The next one, they don't say decimal numbers, so it's 28 divided by 10, which is 14 divided by 5. 14 divided by 5. The next one is -7 over 2. For 6, we get 14. And then for the last one, they don't want 11.2. We have to come up with a fraction. So 56 over 5. Waste of time, total waste of time on this part. Okay, let's see what I did. So with -6, 42 over -9. Oh yes, we can simplify by 3, sorry. Yes, the first one is 14 over 3. I didn't simplify. Sorry about that. Okay, so now the graph, we know that the horizontal asymptote is 7. So the first one is not important. We are only looking between B and D, right? So it's not B because it doesn't go from 7 to infinity. So it's D because it goes from, crosses the graph at the origin, and it's going from 7 down to negative infinity, and then from positive infinity to 7. So that's D. It's the only one. Is it clear?
Yes, thank you.
But again, if you want to stop sharing for a second, I will never ask you to do this. Everybody can plug numbers in the graphing calculator and get a fraction or a simplified form. This, if you understand this, from here you can answer anything. Because all the information is summarized in one spot. And that enables you to graph the function quickly.
So we won't see that 7th step on the test.
No,
You just want the table.
these are the 7 steps. These
Okay,
are
just all
all
together.
the 7 steps right here. The x and y intercepts, the vertical asymptote, the behavior left and right, the horizontal asymptote. Everything is here. And I don't care for points. You can plot as many points as you want. However, there is no need. Okay, so let's take a 10-minute break. I'm going to get more water. And I'll keep quiet for 10 minutes, I promise.
Your call cannot be complete.
Take a look at these creatures and one dancing poop doing the Macarena.
Did you want to show me something? Did you want to show me something?
Is it difficult to get a life and health insurance license?